In this section, we want to see how parallel lines and perpendicular lines can be described, or can be how we can observe that we have parallel lines or perpendicular lines by looking at the slope of the lines. We also want to solve problems such as here's a parallel line, here's a line, and here's another line that's parallel to it that passes through this point. What is its equation? Or here's a line, I give you its equation, I give you a point here, or a point there, that's okay. It doesn't have to be on the line. I give you a point, find me a line that's passing through this point and perpendicular to the given line, and give me the equation of that line. So we're going to be solving these problems in this section. So we start with parallel lines. Okay, and let's see how their slopes are related. So maybe let's position them in the xy plane. Okay, now if I look at this line and I pick 2 points like this, okay, and this is delta y, this is delta x, okay. If the other line is the same, I could essentially take this triangle and bring it over here and it would fit, right? Essentially I would have its hypotenuse on the line. So for parallel lines, the rise over the run is always the same. So delta y, which is over delta x, which is the m, is the same. So that's how I can identify or characterize lines that are parallel. They have the same slope. So here's an example. Find the slope of the line parallel to 5y minus 2x equals 7. Now notice that the equation of the line here is not in a form we've seen so far. It's not in slope intercept form or point slope form, but we can make it into and put it into slope intercept form by just solving this equation for y. So if I do this, I get 5y is 2x plus 7, and solving for y I get 2/5 of x plus 7/5, and now it's in the form mx plus b. Okay, so this is slope intercept form. I don't care so much about the intercept as I do care about the slope. So this is my slope here. So I wrote find the slope of the line, but I meant the slope of a line. So let's change this. The slope of a line parallel to this line. Well, the slope would be, for any line parallel to that line, would be 2/5. That's it. We just have to identify the slope of the given line. And maybe this is part A. Part B, find the equation of a line parallel to 5y minus 2. I have 2x equals 7, and passing through the point 1, 2. Now, okay, from part A, I know the slope of that line will have to match the slope of the given line. So slope is 2/5. I've got a slope and I've got the point, so I'm going to use point slope form because I don't have to do any sort of work. So the equation of the line is y minus the y coordinate of the point is equal to the slope times x minus the x coordinate. I could also solve this for y. I kind of like to do that and give my answer like this. So that's the equation uh, of the line. All right. Perpendicular lines. Okay, let's draw a diagram of a line. Okay, now imagine I draw a right angle rectangle. This is rise. This is the run. This is the rise. Okay, and now suppose I've got this other line here. Okay, that's perpendicular to the given line. So there's a right angle here. Okay. How is its slope related to the one of the given line? So the given line has a slope delta y over delta x. Now, how is the slope related? The slope of the green line related? They should be related, because if I give you this line, you know how to draw the other line. At least draw its direction. So in some way, if the direction specified, the slope specified. So we should be able to recover the slope. So to do this, imagine that this triangle here, I will label its angles by, this is, let's say, alpha, this is beta. Alpha is kind of like, it's a Greek letter that is the ancestor of our A, and this is the ancestor of our B. So alpha and beta, we often use those for arbitrary angles. Okay, for right angles, we tend to use something like that. Okay, now, let us use a different color, I think. Let us extend this line here. So this is all flat. Okay. Now, what is this angle here? Right there. Well, we should remember something about angles in a triangle. If I look at the sum of the angles in my first triangle, right? So this angle, that angle, that angle. If I add the angles inside a triangle, they add up to 180, don't they? So what does that mean? It means that, yeah, okay, let's keep it this way. Of course, it means that also alpha plus beta is 90 degrees. But let's look at this. Okay, alpha plus beta plus 90 degrees is 180. Let's look at what we have here. This is alpha. This is 90 degrees here. So what's the other angle that's missing here? That's beta, because they all need to add up to, this is beta right there, because they need to add up to 180, right? Because it's a flat line. So right, if I've got a flat line and it's split up like that, all these angles here, they need to add up to 180. That's exactly what I have here. So this is beta right there. So which means that, let's say I take this triangle here, okay, and I flip it in order to position it like that. Okay, you can see I can do this now because this angle here is beta, this is a right angle, so this must be alpha. Okay, and let's say they have, right, it has the exact same length as the other one. So maybe actually let's do a better job. I don't have same length. That looks more similar. So let's say this is still delta x. Now, since the angles add up to 180, that must be alpha. So essentially what I know is that I have similar triangles here. Those are exact same triangles. So in other words, if this is delta x, this is delta y. Okay? So let's label my lines. This is L1, A2. So the slope of L1, that's rise over run. But what's the slope of L2? Okay. Well, if I look at the run now, here is this should be delta y. I'm really sorry. Let's backtrack a bit. This is delta y right there. I made a mistake. Okay. Sorry if you were lost before. Okay, so these two triangles now are similar, right? So this side here, it's right there, right? So okay. So the slope of L2, let's look at the slope of L2. Now if I look at this triangle here, okay, the run is right there. So it's actually delta y. The run is delta y. But if I go forward by delta y, I will go down by delta x. Look at this side here, right? That's how much we go down. So the slope of L2 is related to the slope of L1. It's the opposite of the reciprocal of the slope of L1. So maybe I can write that opposite because of the negative sign of the reciprocal of the slope L1. Okay, let's go and look at an example. We want to find the equation of the line perpendicular to 5y minus 2x equals 7. I notice it's the exact same line we had in the previous examples. And now passing through 1, 2. So the slope of the given line is, well, I'm not going to redo that. We I'd calculated it before, so that's it's 2/5. Okay. So the slope of the perpendicular line is going to be, okay, we take the reciprocal and the opposite. We hit that with a negative sign. Notice if, let's say, the slope is minus 3/7, you take the reciprocal, which is minus 7 over 3. You hit that with a negative sign, the negative sign will go away, right? Minus minus will give you a plus. So in other words, one's positive, one's negative, right? So if the given line has a positive slope, the perpendicular line has a negative slope, and it's the other way around otherwise. Okay, so I've got my slope, and I've got a point, okay? So the equation can be easily obtained in point-slope form. Is y minus the y coordinate, which is 2, is equal to the slope times x minus the x coordinate. And we're just done. If you don't like it this way and you prefer to have y solved for, you can do that too. You can write it like that. Both are just as good. Now, there's also one thing I'd like you to notice. If I take these two, okay, and I multiply them, what do I get? Get 2/5, and the other one is the reciprocal hit with a negative sign. So we realize that 2/5 times 5/2, that's going to give me 1, but because of the negative sign, I'll get minus 1. So this is always going to be true, okay? Since the slope of the perpendicular line is the opposite of the reciprocal, then we have the following result. If two lines with slopes M1 and M2 are perpendicular, then M1 multiplied by M2 is going to give you minus 1. So it's actually a way also of getting the slope of the perpendicular line. So if you're given that the slope is 2/5, the slope of the other line is such that when you multiply it by 2/5, you get minus 1. So now after multiplying by 5/2 on both sides, you're going to get minus 5/2 for your slope. So that equation can be used to get the get the slope of your perpendicular line. So we'll finish with one quick example. We want to find the equation of the line passing through 3, 4 and perpendicular to x equals minus 2. So it's very tempting to use this in order to recover the slope of our perpendicular line. But look, we're given a line x equals minus 2. X equals minus 2 is a line like this, right? It's all the x coordinates of points on this line are negative 2. It's a vertical line, okay? So this is a vertical line. So all lines of the form x equals c are vertical lines. Has no slope, right? So I cannot actually use a slope to get the slope of the perpendicular line. That one has no slope. So this is an example of a line with no slope, and where you cannot use what I just mentioned before. So, but however, we know that a vertical line, its perpendicular line, is a horizontal line. So if it's passing through 3, 4, it means it's the horizontal line passing through 3, 4. Horizontal lines have equation of the form y equals c. Now what's y? Y is the constant is the y coordinate of one point that belongs to that line. So y equals 4 is the line we're looking for. So y equals 4 is perpendicular to x equals minus 2. So in general, if you've got a line x equals k, it's going to be perpendicular to a line of the form y equals c, and vice versa.